Hi there. In this webinar, we're going to be thinking about how sequencing develops in coding across the primary curriculum. I'm going to assume that you're already using ToCode with your children, perhaps because you're using the computing scheme of work, or maybe you're using some of the activities already within ToCode. To begin with, I want us to think about how sometimes it depends on what order you do things in. These two actions here, does it matter whether you take a bite of your sandwich first or take a sip of water first? Usually it wouldn't. You could do it in either order and you'd still enjoy your lunch. What about these two? Does it matter what order we do these in? Yes, it does. We have to put the key in the door first so that we can turn it to unlock it. What about these three things? What order should these be in? Brush your teeth for 2 minutes, wet your toothbrush, and apply toothpaste to the toothbrush. Well, we're going to have to do brushing your teeth for 2 minutes last, because otherwise we're not going to have a wet toothbrush with some toothpaste on it, and it's not going to work, is it? However, saying that brush your teeth for 2 minutes comes last is quite important, but it doesn't matter what order we do the first two in. Whether we put the toothpaste on first or wet it first, we're still going to have a wet and pasty brush to clean our teeth with. Sequencing matters when things depend on one another, and it's an idea of cause and effect which we're familiar with across the wider curriculum. Where else did learners use these skills? Well, deduction and inference. Why might? Why does this happen? Deconstructing and explaining things. This can happen in science when we're having to explain a science result. In PSHE or history, we might ask the question, why did they do that? And children have got to sort of go back a step and try and work out what happened before to make that happen. We also get them to think about a cause and what the effect might be. And this happens when we're planning or making predictions. So we might be mixing two colours together in art. What colour do you think it's going to make? We might be thinking, how can I make my character seem exciting? Or we could be choosing a flavour that will make people enjoy our food in DT. They're really cross-curricular skills, and children should be familiar with them from outside of computing as well. And if you can introduce that, I think it helps to make computing seem a little bit less scary. How can we teach dependency connections explicitly, though, in computing? Because in computing, they do become a bit more critical, perhaps. So think of the steps to make a sandwich, a peanut butter and jam sandwich I'm thinking of here, without margarine. And you could get the children to write them down. And then they might end up with a list something like this. And you might get the children to think, could any of these be swapped round? Could any of these not be swapped round? Do any need to come at the end? And you can get quite a lot of mileage out of this. And you could maybe make the sandwich according to the children's instructions and have a bit of fun with it. So here we are in ToCode, and I've got my two commands here, tuna moving right and crab moving left. And time is flowing down the page here. So first it's going to move the tuna right, and then it's going to move the crab left. And when we run it, because I'm in slow mode here down in the bottom right-hand corner, those instructions happen slowly, and we can watch them happening one after the other. In this case, though, where the clownfish moving right at the bottom is going to happen, but it's not going to happen until this top instruction's happened. It depends on what's up here. So within here, I'm dragging in the when clicked block. I'm going to say when I click on my clownfish, and then I'm going to drag the clown in here, and we'll say make the clownfish move right. So when I click on run, nothing happens. That's because I need to click the clownfish, and then the dependent action, clown moving right, starts to happen. Easy. We can also have something else in here. So I can also pop in here, the tuna is going to go left. Now, when do you think the tuna will move left? Because the tuna is also tucked in beneath the when clicked clown event, it too will wait for the clown to be clicked. It will depend on it. So here we go, we click on the clown and both of the fish start moving because they both depend on the clown being clicked in this instruction. And lastly, something that can be a little bit confusing at first is if I arrange the blocks like this, what do you think would happen now? So as we can see, in this case, the tuner has started to move left well before the clownfish has been clicked, even though this when clicked command here comes before tuner in the program. I now click on the clownfish and away it goes. So the program doesn't wait for anything inside the when clicked to happen before it carries on to the next blocks down on the left-hand side, which is important to know. This can also happen where you have code such as this, where we might have the rabbit will hide, but it depends on the timer waiting 5 seconds first because it's nested under the timer control. So what I'd like you to understand so far is that timing flows downwards on the commands, but dependency flows across as well as down. So as you can see here, because the clownfish and the tuner, they're both tucked across here to the right, so they are depending on something that is above them and sticks out to the left. So that's a good way of spotting it. We also have the idea of dependency on selection, and this crops up around year 4 in the curriculum, where we will select an outcome depending on a situation. The knight will go left in this case, but it depends on its x coordinate being more than 15 first, because it's nested under the if control. So we can see here, if the knight's x is greater than 15, then make the knight go left. An example I've got here is, you can see this block of code we're looking at says, if an input that somebody's already typed in is equal to morning, then we're going to print onto the screen good morning, or else we're going to print good afternoon. So we use the if-else block when it matters what happens if this top check is not true. These are separate blocks. This is an if block here, and this is an if-else block here. These often come together in activities like Genie, which happen around year 4. And it can get a little bit tricky here, particularly if children are not confident with the idea of dependency through the work that they've done already on when clicked, ifs and timers and so on. So here I am at stage 2 of the Genie activity, and what you can see is we have the brass lamp here, which every time I click on it, it's going to add 1 onto a computer's bit of working memory, a place called count. So I click onto the lamp and you can see count equals 1, click again, count equals 2. Now what we want to do is to check that when count equals 3, we're going to change this into a Genie. So we need to move on to the next challenge here, which is where this happens. So we need our if statement, because we're going to be saying if the count has got to 3, so that's our condition, then we want the lamp to change its image to a Genie. Now, I've done this activity with children a lot of times, and a lot of them will read this through at the moment and think it works, think it's going to be absolutely fine. So we'll click on to run, and the children will click on the lamp, clicked it once, clicked it twice, clicked it 3 times. It's not changed. What's gone wrong here? There's a really handy feature in TwoCode that whenever you click on the lamp here, the code that was running when we click on the lamp will flash in orange over here on the right. So if I just click the lamp a few more times, notice which part of the code is running every time. Do you notice that it's the add 1 line where we're adding 1 onto the counter? So a great thing that I would say to children now is, when do you want to do the if check? And they have to really think about this. Do you want it to happen at the beginning of the program? Because that's what's happening now. If I click run and you watch, as soon as I've clicked on run, it will flash orange the if. 3, 2, 1. It flashed orange. We're not going to see that flashing again because it's just on the standard time flow of the program. It doesn't depend on anything other than time to make it happen. So we need to get the children to answer the question, when should it happen? And you need to be prepared to give them some time to think, because the only other time that it could happen, they'll hopefully realise, is when we click on the lamp. So you could say, I want it to happen every time I click on the lamp. And now they do it. Once that's been tucked in here and is part of the when click lamp group, every time we click on the lamp, you'll see that the if has been flashing orange. And the third time I click it, it will change to a Genie. So the lamp changing to the Genie depends on the if. And the if has to depend on us adding 1 on. We want to do that after we've added 1 on to see if it's got to 3. And adding 1 on only happens when we click the lamp. So we've got a chain of dependencies here, haven't we, which you can see by this whole sort of list of things going down and out in the program. So help children to clarify by asking when. So as you can see here, when should it change the image? To which they'll hopefully reply, if the counter has got to 3. And you say then, when should it check if the counter's got to 3? And that's hopefully when they'll say, after I've added 1 onto the counter. Okay, and when should it add 1? When I click on the lamp. And that series of questions will expose the dependencies and the sequence within this bit of code here that we need. It does need practice. This doesn't come particularly easy for children. So get them to explain images like this. Create some yourself in code and print them out and just get them to tell you what's going on. And get them to possibly try, if they need more reinforcement, get them to try activities like switching background and night and day, because it's really important that they are confident in how this works. Otherwise, when they get to year 5 and 6 coding, things are going to get a bit tricky at times for them because it does get more complex. What I'm looking at here is some children's work from one of the lessons in the Year 6 computing scheme of work. And there's quite a lot of in and out action, isn't there, where the code is jumping out a step here, going in, out another step, in a step, out a step, out a step, in a step, in a step. It's quite complex what's going on here, and we've got an if-else block with another if-else block inside it. So I'm sure showing you that this is where the children end up in Year 6, producing this kind of coding, can hopefully help you to appreciate the importance of getting this idea of dependency and sequencing correct earlier on in their computing activities in the schools. When I run this program, if I do run it, it's lovely because it asks the children what's your name, so I'll pop my name in there. It asks me what colour's my alien. I'm going to click it's a blue alien. So it's going to run the code here on the blue tab. How many eyes does my alien have? Now I'm going to say it's got 2 eyes, and I'll say OK. And it's gone through this if and selection here to tell me that my alien is Rini, which is absolutely correct. There were other alternatives here. If I put 1, it would have told me my alien was Ram. And if I put anything other than 1 or 2, it told me it would say that we don't know that alien. Please let NASA know about it, which is fantastic. There is a more complex version of this, which some of your higher achieving children could possibly get onto. Let's see if I can find that one. So we're on this one here. And it is possible that children can end up producing things like this. And this is a child who didn't just do the activity with 6 aliens, but she wanted to produce the sorting activity for 20 different aliens. And this is just one of the tabs that deals with blue aliens. Now, the amount of thought and logical understanding and planning that's had to go into her doing this is actually really quite impressive, I think. And to help children to, you might want to get them doing things like this. Give them printouts and ask them to draw lines on it to show where the flow is happening. And what happens, then what happens next? What's happening next? And just drawing lines on it can help the children to think from here it goes to here, and then it goes to here and checks if, and then it goes to here and checks, does a print on the screen, but if it doesn't, if that's not true, that it doesn't equal 2, then it's going to jump across to the else and end up by printing that. Just getting them to talk through and explain things is so, so important. Then when it comes to them creating their own versions of these, give them pieces of paper to draw on, to make notes on. They can produce flowcharts like this. If the input is the input 1, yes, print this message that the alien is Ram, or no, then check that the input is 2. If it is 2, then print the message as Rini, and if it's not, then print the message that the alien is not known. So it's really important that you give children these opportunities to develop their logical thinking so that they can go ahead and solve things like the alien Guess Who when they are in Year 6. Creativity uses these thinking skills. Computing itself can be a very creative activity, but beyond that, These thinking skills of predicting and using cause and effect are used in art, architecture, engineering, science, marketing, you name it. There's many, many opportunities. Thanks ever so much for watching. I hope you found it helpful. Goodbye.